Hey guys, today we are taking a deeper dive into how we handle negative exponents and what it means to have an exponent of 0. So I have this set up originally as kind of a discussion thing where you guys would discover it, but we're just going to walk through it together and we're going to just kind of discover it through me. I'm just going to, kind of help you make those connections. So we're going to go through, I'm not going to do every single one of these just because we should be able to pick up on the pattern after 2 or 3 of them. Because what we're going through and evaluating, we're trying to try and find some patterns of what happens when I increase or decrease my exponents. So if I start with this far left table, we're just doing different exponents on a base of 2. We know that 2 to the first power is just 2. That's just 2 multiplied by itself once. I'm going to change the color up here. 2. 2 squared is 4. 2 times 2 is 4. You can use a calculator for this if you want to go through and do these, but again, just follow along. 2 to the third power, if I multiply by 2 3 times, that gives me 8. 2 to the fourth is 16. 2 to the fifth is 32. 2 to the sixth power is 64. And 2 to the seventh power is 128. If you need to use a calculator again, 2, your little exponent button, and then 7, hit equals, and we should get 128. Okay, let's take a look at this next table. Doing the same thing with now a base of 5. 5 to the first power is 5. 5 squared is 25. 5 to the third power is 125. 5 to the fourth power is 625. 5 to the fifth, 3,125. 5 to the sixth, 15,625. And 5 to the seventh power, 78,125. We could do it again with the third power if we wanted to. All of these, again, very straightforward stuff in terms of just evaluating 3 to the whatever power on your calculator. So this should be 3, 9, 27, 81, 243, 729, 2,187. And our powers of 10 are kind of a cool shortcut where basically anytime you have a 10 as your base, the number, the exponent that's attached to it, basically just tells us how many zeros there are in your answer. So 10 to the first power, 1 0. 10 to the second power, 2 zeros. 10 to the third, 3 zeros. 10 to the fourth, 4 zeros. 5 zeros. 6 zeros. And then 7 zeros. Whew. So what we're trying to do is figure out a pattern to get from one to the next. So here our arrows look like they're going up. So we're trying to see, all right, well, just a direct shortcut for how we can get from 2 to 4, and then use that same rule to get from 4 to 8, 8 to 16, 16 to 32. And we should be able to tell here 2 times 2 gives me 4. 4 times 2 gives me 8. Times 2 gives me 16. Times 2 gives me 32. Times 2 gives me 64. And times 2 gives me 128. So you can see all we're doing here is just multiplying by 2. In our second table, going from 5 to 25, we multiply by 5. 25 times 5 is 125. 125 times 5 is 625. And you can see here the rule again, I'm just multiplying all the way through by 5 for each step to get from one to the next in my table. Which, without having to necessarily guess at the rest of them or check them, we should be able to tell that all of these are going to be multiplying by 3. And again, without testing it or checking it, having to think on it too deeply, I know that this is going to be multiplying by 10. And the reason that it's multiplying by 10 here and by 3 in my other one is because all I'm doing is multiplying by whatever my base was. Because that's what happens when you increase your variable by 1. Or sorry, your exponent. If I'm starting here at 2 squared, this is 2 2's being multiplied together. If I increase that to now 2 cubed, I'm taking what I started with and just multiplying by an additional 2, by an additional base. So multiplying by 2 is how we can get from one exponent to the next highest one, which is going to be important for us because now if we go to page number 2, we're going to just skip over those questions again that are on your worksheet. We're just going to go right into the second set of tables. Is what happens now if I start going backwards. So if I start at 2 squared, which we knew was 4, 2 to the first power is 2. Those are the only two ones that I know so far. If I'm thinking in the opposite direction, if now I'm going down my list, going down by exponents, instead of multiplying by 2, I should be doing the opposite. I should be dividing by 2 to get my next one in the pattern. Which means 2 to the 0 power, I still have to divide by 2. So 2 to the 0 power would be positive 1, because 2 over 2 is 1. If I divide by 2 again to get down my next one in the table, 1 divided by 2 is a half. A half divided by 2 is a fourth. A fourth divided by 2 is an eighth. And then an eighth divided by 2 is a 16th. A little bit weird, but using our pattern, that's what it looks like. Let's take another look over here at our 5th power ones. We'll just do these two because we should be able to develop the pattern and recognize it. So 5 squared we knew was 25, and 5 to the first power is 5. That's from our table up above. And we know I have to divide by my base in order to decrease my exponent, right? So 5 squared divided by 5 is 5. So then 5 divided by 5, once again, is positive 1. I divide by 5, and now this is 1/5. I divide by 5, and this is 1 over 25, 1 over 125, and then 1 over 625. So if we notice that what we ended up with, the bases, so I'm going to just start highlighting some stuff here in yellow. My bases, or my denominator, with my negative exponents, those are the values of 2 to the first power, 2 squared, 2 cubed, and 2 to the 4th power. Right, in here, what I'm going to write here in red, this is 1 over 2 to the first power. This is 1 over 2 to the second power, 1 over 2 to the third power, and 1 over 2 to the 4th power. Because 2 to the 4th power is 16, 2 to the third power is 8, 2 squared is 4, 2 to the first is 2. So this is kind of that intermediary step, the number that we ended up with on the far right that's written in blue with the highlight in yellow. That's fully simplified, evaluating the exponent. But this conversion, this that I'm going to highlight in blue here, is how we handle those negative exponents. I can just take that base and that exponent, keep them the same, but I have to flip it over to make my exponent positive. The same thing applies over here for our base of 5. This is 1 over 5 to the first. This is 1 over 5 squared, 1 over 5 cubed, 1 over 5 to the 4th. So that's our shortcut. That's how we handle those negatives. So if I wanted to, without having to like fully simplify stuff, this is 9, this is 3. We know that anything to the 0 power, right? If you notice, both of them were the same. 2 to the 0 power was 1, 5 to the 0 power was 1, 3 to the 0 power is 1, 10 to the 0 power is 1. It's a little bit funky and it's a little bit weird, but it's because we're not multiplying or dividing by any of the 10s or any of my bases, so it's just that positive 1 for all of them. And then this could be 1 over 3, 1 over 3 squared, 1 over 3 cubed, 1 over 3 to the 4th. Depending on what you do and don't have to evaluate, we can leave it as just our base and our exponent form. So, summarizing some stuff here, I'm going to go down here to number 10, what's labeled as number 10 on the worksheet here. What is the rule to summarize the property of any number to the 0 power? So we'll just say any number to the 0 power equals 1. Any number to the 0 power equals 1. Now, it's a little bit different. We didn't explore this here, but it will pop up on the homework that you guys are working on today. 0 to any exponent power, we'll just say n, or there's any number. 0 to anything is just 0. Because again, if 0 is my base, 0 times however many zeros we want would be 0. So that's a little bit different. Anything to the 0 power, if 0 is your exponent, your answer is 1. If 0 is your base, your answer is 0. Our rule to summarize our negative exponents. So for our negative exponents, again, we could say that we have to flip it over and evaluate with the positive exponent. So again, if we wanted to come up with an example here, we could say 4 to the negative 7th power. If I was going to evaluate this, if I'm going to evaluate with the negative exponent, I would have to flip it over and evaluate with my negative, or with the positive exponent. Just my exponent becomes positive. So if I was going to leave it like this, that's fine. You wouldn't necessarily have to evaluate 4 to the 7th power, but if you wanted to, this would be 1 over 16,384. Again, like we talked about on Friday, the important thing here is only the thing that has a negative exponent on it gets flipped over. If I had multiple different bases, only the thing that has a negative exponent on it gets flipped over. And only the sign of the exponent changes. My base stays the same. My number for the exponent stays the same. It's just that now, once I have flipped it, my exponent becomes positive. All right, that is all I got for you. Your homework for this section is the exponents worksheet. You've got its front and back. You guys are just evaluating with negative exponents, 0 exponents, or 0 bases. As always, if you guys have any questions, concerns, thoughts, ideas, hopes, or dreams, make sure you guys are reaching out and letting me know. And have a fantastic day. We'll see you soon.